lobe-fin fish, a lineage, and it made this transition towards tetrapods. Okay? I had this on a t-shirt. I can't find it to wear on a day like this. Out of the ooze and born to cruise. So, tetrapod origins. We'll hit it real quickly here. I want to kind of review some of the ideas, and then we'll do it in more detail after our break as we move into tetrapods. See this lobe-fin fish here? There's a reconstruction. A coelacanth-like fish. This is not a coelacanth, but it's a coelacanth-like fish. It's kind of the version of coelacanth. Like, there's ancient times we had coelacanths. Coelacanths were mostly marine in the oceans. And this type of fish is a freshwater lobe-fin fish. And this is the thing that's the evolutionary raw material for tetrapods. And look at the lobe fin there. This is the pectoral girdle, right here. That's the clavicle. No, that's the clavicle. And that's the lobe fin. There's the rays, and there's a series of bones in here. And these bones, to get ahead of our story, these bones are going to get repurposed and reformed, and they're not going to support a fin for swimming. They're going to support a limb for bearing weight. And these are the bones that are going to become the upper arm and the lower arm. One upper, two lower. That's the raw material. Let's see, it's your classic fish out of water story. Really scared, wants to flop. This is another just piece of art, which is kind of interesting. This is a classification system. This is a classification with people right here, hominids in the middle, but each of these circles would be a monophyletic group. And you can see a classification system is just an increasingly more inclusive nesting set of monophyletic groups. You can see we do the whole thing here: chordates, vertebrates, bony fish, chondrichthyans, ray fins, lobe fins. Get that on your screen and move your finger around it, and it actually summarizes this whole thing I put on the board. So, there's a whole lot going on here as we transition from aquatic living creature to terrestrial creature. But limbs for locomotion instead of lobe fins for swimming, that's generally the cutoff point. Once we have limbs for locomotion, we're talking tetrapod. In a loose sense, not in a synapomorphy, but in more loose sense. So these are some of the lobe-fin fishes we're talking about. This is all in the fossil record. There are no survivors in this group. We have coelacanths, and coelacanths kind of give us an idea of what this animal might have looked like, but coelacanths are marine. These were freshwater creatures living in swamps, probably. And these are some of the fossil things in the story here. These are reconstructions of them. Eusthenopteron is a really well-known one, as is a creature called Panderichthys. And look, ichthys, this fish right in the Latin word there. But this is some of the pieces of the puzzle.
How do you know they're freshwater?
The question is, how do you know they're freshwater? The sediments will tell you that. The matrix that the fossil is in, you can tell if it's been formed in freshwater or saltwater. So, Eusthenopteron, that's a fish, and that's, again, this lobe fin there. And then this is a very primitive tetrapod, Acanthostegia. And there's that lobe fin being repurposed, being reformed into a limb. And it wasn't a limb overnight. Remember, evolution gives you good enough, better than anyone else. And with nothing else roaming around, that was good enough and better than anyone else, even though something like that today would get chowed by a bird in a second as it lumbered and flashed around in the mud. It's my favorite transition picture. I found this on a website, a creationist website, where they were trying to dispute any idea that evolution occurred. And they showed lobe-fin fish crawling up on a beach one day. A little more complicated than that. And I always point this out. Oh, I have to bring my copy. There's an awesome movie called Humanoids from the Deep, where lobe-fin fish, coelacanths, in the movie they call them coelacanths, but lobe-fin fish crawl up out of the ocean in Northern California and start mating with comely beach babes. about as good as it sounds. We don't have a lot of ichthyology horror movies, so we take what we can get. I'll bring it in if you want to borrow it. It does have nudity and violence, so I should say that. Not a family film. So again, not like this, certainly not like this, much more like this, and I'm going to talk about this after break, but imagine we have a freshwater pond, or a stream, or a river, whatever, a freshwater habitat, and freshwater habitats are prone to drying out in droughts, or even seasonally in the summer. And if you're a fish in a freshwater habitat that dries out, too bad. But these are some placoderms, too bad for them. But what if you're a lobe-finned fish? You're a bony fish, so you have lungs, so the water goes away. If you're still wet, you can breathe with your lung. And you've got your fins on the end of these little stumps. They probably evolved for these fish to sit in weed-choked water on the bottom. But that's basically a pre-adaptation, a handy tool that just has to be there for dragging or rolling or pulling yourself from this dead pond, maybe just through some wet grass into the nearest river. And that's the origin of terrestrial tetrapods, an emergency. And these guys had the adaptations to deal with that. And so they got to push that body form, that set of adaptations, on in time. These guys didn't have that. Like a normal fish, pond dries out, you're gone. And I just love this fossil. These are tetrapod footprints, or that's what they're interpreted to be. Very early tetrapod trackways, maybe something like Acanthostega, walking along on a muddy bank, maybe walking in the bottom of a swamp, putting his feet in the mud. Okay. Let's take a break. Let's come back a minute, 10, maybe a few minutes after 10. This is where I thought I'd be Friday, so we're